Our goal in problem 1 is to find the antiderivative of the function 3x squared plus 4x times cosine of 9x. Our aim in this problem is to find the antiderivative of the function 3x squared plus 4x times cosine of 9x. Let us integrate the function 3x squared plus 4x times cosine of 9x. It comes that, at first glance we easily see that the function we have to integrate is a product of a nonlinear function, cosine of 9x, with a polynomial function 3x squared plus 4x. Often, when you are faced with this type of complex integration problem, you have to adopt the appropriate strategy that will help you simplify the problem, and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2, for solving integrals that involve the products or quotients of nonlinear functions are the U substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. As a matter of fact, the polynomial function 3x squared plus 4x is of degree 2. Thus, our first goal will be to reduce the degree of the polynomial function to 1, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v, minus the integral of v du. In sum, we set u equal to 3x squared plus 4x, so du equals 6x plus 4 dx. And dv equals to cosine of 9x dx, and v equals to 1 over 9 times sine of 9x. Lastly, the integral of 3x squared plus 4x times cosine of 9x dx is equal to 3x squared plus 4x over 9 times sine of 9x, plus the integral of minus 6x minus 4 over 9 times sine of 9x dx. Consequently we still have to integrate minus 6x minus 4 over 9 times sine of 9x, using integration by parts. Let us integrate the function minus 6x minus 4 over 9 times sine of 9x. Given that the function to integrate minus 6x minus 4 over 9 times sine of 9x is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function, minus 6x, minus 4 over 9. Thus, we set u equal to, minus 6x, minus 4 over 9, so du equals, minus 2 over 3 dx. And, dv equals to sine of 9x dx, and v equals to, minus 1 over 9 times cosine of 9x. In sum, the integral of, minus 6x, minus 4 over 9 times sine of 9x dx is equal to 6x, plus 4 over 81 times cosine of 9x, plus, minus 2 over 3 over 81 times sine of 9x, plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of 3x squared, plus 4x times cosine of 9x. The first integration by parts gave the following result. So, the integral of 3x squared, plus 4x times cosine of 9x dx is equal to 3x squared, plus 4x over 9 times sine of 9x. plus the integral of minus 2 over 3 over 9 times cosine of 9x dx. From the second integration by parts, we obtain the following result. So, the integral of minus 2 over 3 over 9 times cosine of 9x dx is equal to 6x, plus 4 over 81 times cosine of 9x, plus minus 2 over 3 over 81 times sine of 9x plus a constant of integration c. As a result, combining the last two results, we see that the integral of 3x square plus 4x times cosine of 9x dx is equal to 3x square plus 4x over 9 times sine of 9x plus 6x plus 4 over 81 times cosine of 9x plus minus 2 over 3 over 81 times sine of 9x plus a constant of integration c.